Welcome everyone on this one of the last talks of JFO for 2023. Thank you for coming to my talk. The talk is called Case Against Frameworks. We'll get into that in a few moments, but first I want to hear if anyone is here by reference from Tom Cool's talk. 2, 3, 4. Okay, so he referenced my talk in his talk because he says you should use frameworks for all the goodies they do and for all the benefits they give you as a team. To put it in his words, I'm going to butcher his story. Well, maybe not. We'll see how far we get with that. But our talks are somewhat linked, and the fun thing is last year on Java Zone we were also both there, and then I was first and he was later. So we'll have to see how things stick when I go second. Anyone else here maybe that was here 2 years ago during lunch break and saw me do this as a lightning talk? Yeah, the usuals. Okay, so that's nice. So the rest, none of you have heard this talk before. That means that you will hear new stuff. And the fun thing about this version is this is the one where I can breathe. I just have to remember to do it. So this talk is the case against frameworks, and the idea for this talk is actually a few years back already, from when I was in a team where we had a framework imposed on us from the organization, and we worked with it. We used some of the features of it. We also deliberately not used some of the features of it. Because we didn't want to have the framework invade our code too much. And this was going fine, and some part of the organization always keeps asking, like, why aren't you using this Spring feature? Why aren't you using this Spring feature? Oh, I said which framework it is. Okay, well. And we usually had good ideas for that because one, we didn't need all the complexity maybe, or there was something else we needed. And then there was a sprint once upon a time where we deployed the new service, and when we tested it at the office, everything was fine. Nothing weird, nothing out of the ordinary. But from time to time, when people were working from home, we got messages like, I tried calling the service and it works, and then it doesn't work. And then it works, and then it doesn't work, and we have no idea what's going on. I think if I'm going to explain what happened along the way, you might get an idea of what the problem was. If you start snickering, then I'll know you figured it out. I'm going to explain it anyway, but the point is, what we had was a service that uploaded the file. And you upload the file, it takes a while, and it would fail after you uploaded the file. And if you upload a big file, this can take a while. And the problem is if you have to wait for a long time, like the keynote speaker said, you get bored, and then you go back to your upload and you see it failed. Oh, damn it, why did it fail? And now I have to retry it and try to figure out what happened. And again, when we were at the office, everything was fine. Nothing happened, all uploads worked, but from home, it didn't. So we finally traced it to a point where we said, okay, it's a problem with Keycloak. We are uploading a file, and for some reason Keycloak says your request is not valid. And when we started debugging that, we saw Keycloak actually says your token has expired. Some snickers, maybe? No, not yet? Okay, cool. So I have a little more detail here. What happens when we upload a file from the VPN that's throttled? Our token expires somewhere halfway through the upload. We store the file on disk. Then we go to Keycloak and say, listen, this person wants to upload this file. He gave me this token. Is that okay? Because I need his credentials. And Keycloak says, well, this is an old token. It's more than 5 minutes ago, so no. And you get a 403 denied from your upload. And this took us quite a while to figure out that this was the problem. And the problem actually was, in this case, Spring. We looked at what Spring does when you upload a file, and what it does is this. As your client, you upload your file, Spring reads the entire request, stores the header in memory, puts the file in a temporary file on disk. Then when everything's done, it looks to its mappings and it goes through all the interceptors and sees, oh, I have an OAuth interceptor. Okay, cool, I have an authorization token, so I'll go to Keycloak and I'll ask if this token is valid. But by then it was expired. And we had no clean way to get this done before the file was uploaded in Spring. So we looked at it. There were ways. You can hack into the interceptor chain. You can try to catch some of the request handling before Spring actually gets it. But that all felt wrong, icky. So what we ended up doing was we changed that particular service to Vertex. And that fixed our problem. And the reason why is that Vertex allows you access to the headers as soon as it read it. So it reads the headers, it calls the header handler, and in the background it still continues to accept the uploaded file. But you can do the OAuth callback before the file completes. So you can even, this is even better, you can cancel the upload if it's not valid, instead of waiting for 5 minutes and then saying it's not right. So this was the reason we started with this talk, like, oh, framework, Spring. We had plenty of other run-ins with Spring. So yes, if you think he's going to ramble about bashing Spring for an hour, don't worry, I'm not going to be doing that. Because that's probably going to be, well, I think boring, but I heard some so maybe I should also make a talk all the bad sides of Spring, but but that's not the point of this talk. The point of this talk is that in this team, we also notice, especially in the teams around us, that there is a set of behaviors in our industry that I wanted to address with this. And specifically, it is that people we as developers tend to just go, okay, we know a framework and we just keep thinking in line of this framework and we keep going with it and we never change. And well, at the end of the talk, I hope you will understand why I say that that's maybe a behavior we should do something with. But first, to start talking about frameworks and cases against frameworks, we have to think of what is a framework. Because, well, if we want to make an argument against something, we have to define what it is. So a framework is, if you pull the word apart, it's a frame on which you can do some work, and this frame gives you a base on which you can do further things you can build. So it's a skeletal or a structure frame. There's frameworks for building bridges, to call back in this morning. There's frameworks for doing certain types of research. They are usually a set of heuristics or abstractions to help you do some task that has been done before, and people figured out, well, this is a good way to do it. And if we take it to software specifically, it's usually a set of reusable libraries that come packaged as one. They prescribe a certain way in which you would have to develop your code or think about certain problems. I mean, if you Spring, you do all things with annotations. If you use Vertex, it's more with reactive and callbacks. Spring Reactive, of course, has also reactive callbacks, but usually a software framework has a sort of opinion about how you should develop your software. And they usually provide some sort of abstraction, some layer of abstraction that makes it easier for you to do your job without having to do all the lower abstraction work that's underneath. So that's a framework. Now, we as developers, we love frameworks. How can I tell? Well, just look at how many frameworks there are. This is just a handful of logos that I put in here. If you start Googling for software development framework, you get loads of these things. So there's plenty of them. People enjoy building them. I would even go so far as to say that there's probably a type of developer who likes building frameworks more than apps, and the other way around. So I myself am more of a framework builder. Usually I build an app and then I end up with a framework and a sort of demo app for that framework. But That's just me. So there's lots of frameworks, lots and lots of frameworks. And you might ask, so if we love them, apparently, there's plenty of them, we build them, why do we use them? Well, there's a few reasons why people use them. Some of them I mentioned already in the definition maybe, but they usually provide some unified way to structure your code. Like when Spring was small, it was a new and refreshing idea to just model your code as beans. You know, we didn't have to have all these components that were calling into each other. We could say, okay, we have a bean, and we do some stuff with it, and Spring does some other stuff with it, and then we have our application. So it gives us a unified structure. It comes with plenty of free features, especially nowadays if we look at what is called the Spring framework. I don't think there's anything the Spring framework can't do or there isn't the module for. So they bring features, they bring things that whoever designed it thought, well, it's handy to have this, and I'm going to make this available for anyone who uses it. It makes it easier to switch between projects. So especially if you're a large company and you have 40 teams building applications, it makes sense to say we standardize the framework, which means that if Johnny works on team A and he has to work on team B, he doesn't have to learn a new framework. He can just say, okay, tell me what the problem is, and are you're using the same framework as we are, so my basic context remains the same. And that's a very powerful reason to use frameworks. You can benefit from collective bug fixing, especially if you use open source frameworks. If you find the bug, chances are someone else already found it for you, maybe even fixed it, if you're lucky, or at least gave you some other hints on Stack Overflow of how they ran into the bug and might help you fix yours. And something that management always likes to do with frameworks is there's always this talk about it gives you a faster time to market for new ideas, for new features, etc., because you have this layer of abstraction and unified structures and etc., etc. So that sounds great, right? It's all unicorns and rainbows. But that's not what this talk is about. This talk is about the darker side. Why do rainbows exist? Because it rains. So, for me, I'm going to start building a case against frameworks. And I'm going to start with the first thing that I have against frameworks, and that starts with a list again. I started listing some backend frameworks. And again, this is, if you just go looking for it, most of you probably already can think of like a dozen off the top of your head. If you go looking for them, there's way, way more. And this even gets worse if you look for front-end frameworks. This is a list where I just stopped looking past like 15 or 20 or so. So it's not strange that there's these memes going around like it's been 0 days since the last JavaScript framework. Especially in the front end, it sometimes seems like there's not a day or a week that goes by, or we have another framework that does something slightly different than the previous 45. And there's a community around it that says this is the new thing and this is fantastic and the rest is all crap. And apparently from those 45 people, then again somebody says, oh no, this is crap, I'm going to build another one. So you keep getting new ones and new ones. And I think in the Java ecosystem, this is a little bit less of a problem because we are more, I think we are more unified as a community. JavaScript still feels a bit like it's all over the place. And if people have take offense to that, and I'm sorry, and we can discuss about it, that's fine. But there's a reason these memes are here. There's a reason people say, don't follow others, build your own framework, and go ahead. And if you're into webcomics, this is probably also a familiar one where you say, standards, there's 14 standards, ridiculous, let's make a standard to unify all of them, and then we have 15 standards. And this is also how it sometimes feels with frameworks. So this is what I call the framework jungle. And this can be especially daunting if you're new to the industry, or maybe if you're tasked with thinking of a greenfield design for a new application. And they say, okay, well, which framework are you going to choose? Well, unless you have a very strong opinion for a framework already, if you start Googling, it's easy to get overwhelmed by just how many frameworks there are. Next, let's look at the life cycle of a framework. So a framework usually originates from one person or a small group of people who have an idea. They have been working on something. Maybe they look at their code and they say, we have a repetition of a certain piece of code that we could maybe abstract over. Let's build something for this so we can simplify our code. And then they think, well, if we share this with other people can benefit from it as well. Especially nowadays with GitHub, it's easy to share this. It's easy to put it on Twitter, make videos of it, go to a conference and talk about it. And you get some traction. People notice your new framework. People start using it. If you have some influencers that start using it, it might explode suddenly. And then there's what I call the sort of golden age. That's when a framework has a pretty strong user base, pretty strong development cycle. If you are looking for bugs, or if you find a bug, there's a process to have it developed. But usually there's a fourth phase, and that's a decline. Most frameworks also reach their top at some point, and then either some other framework starts chipping away from their user base, or there's maybe drama in the development community, or name any other reason, and it starts to decline. Maintenance might slow down, people might be leaving the team, people might simply be walking away from it, and you can usually see this by going to GitHub and see that the most recent release was 2.5 years ago. It's like, that feels like a phase 4 framework. So that's the life cycle usually. What happens in the life cycle of any framework is usually the snowball effect. Spring is a perfect example of this. If anyone here knows how Spring started, Spring didn't start as a framework, Spring started as a library. Spring started as a library just for dependency injection. Super tiny, super small, you'd put your beans and outer wired on it, you created the context, and that was all it did. And then you got Spring integration, Spring batch, Spring data, Spring web MVC, Spring web flux, Spring, etc. So people started tacking on features and features and features, and it grows and it grows and it grows. Same thing can be seen, for example, with Angular. If you know Angular from the early days, AngularJS was tiny framework, didn't have a whole lot of features, worked quite nicely. Nowadays, it's also this beam of a framework where you can have all sorts of stuff in, and in the new versions, what they're talking about seems for me even more like language design than necessarily framework design, so not sure where that went. But frameworks tend to collect bloat. And this is also obvious if you go just looking at some numbers. How big is the artifact that I download? So here, the blue bars are Spring, and they are from, let's see, if I add, so I created projects here with similar dependencies in different things. Dependencies, database, a web and database, and then one with all sorts of stuff that you would have from a microservice. And you can see just the gray one, for example, Quarkus. If you start downloading Quarkus, you bring in 91 megabytes of jars just for generating a new blank Quarkus project. And these are numbers from last year, so I don't know what it is right now, but I would expect it's more rather than less. And this also brings me to a side point that I just picked up during one of the other talks today is digital hoarding is a term that I've heard in sustainable computing, etc. Data that we collect, data that we send, all of it costs energy. And so bringing in a large framework also costs energy. Bringing in a large framework for every build, if you're not using caches, please turn on caches, also cost energy. So there's also a reason why you want to stay small. If you don't need it, stay small. You don't want to end up hosting a bunch of data servers just to keep your project running. And with bloat comes performance, of course. So the next slide has a comparison. I need to introduce it a little bit. Between a JHipster application starting up, with not too many things in it, but just some database in the background and some web pages. And the second one is a similar small application that's part of my current sort of study project, where I restricted myself to using 0 dependencies. So the only dependency I'm using there is the Postgres database driver. For the rest, I'm using Java 21 features and only Java 21 features. And if you look at it, you see the startup of both of them. So mine's done, JHipster is still starting. That's also bloat, and that's performance. It takes a while for an application to start up, and I actually don't think I need all of the things it's starting up. Sure, I can probably prune some stuff, but this was a nice application. That's not one of my applications, but the startup gave a nice comparison with my application that starts up in like 2 nanoseconds, maybe. So, second point that I just explained against frameworks, you get some free bloatware. You probably get stuff that you don't need. Next topic is a favorite of mine and also of Brian's, and it's security. I would dare to claim that 98% of developers do not consider security when they simply pick a framework and start working in it. And security is definitely something you want to think about. And this kind of ties in to what I just said in the previous point, because when I taught Java secure programming for Java back in 2008 or something, we had this diagram that we usually showed people. And you have on the left side features you need for your application, and on the right side you have features that the framework provides you. In the middle you have the part where the framework is helping you. On the left side you have to build that yourself or find some other framework or library to do it. But the right side is the danger. The right side is stuff you don't need, but is in the framework. And if you take any sort of application server that's packaged in with Spring Boot Web Starter, by default, those usually have configuration or management ports that are open. If you're not aware of them, you might just be opening a port that allows anyone that knows about it to connect to your application and start fiddling with JVM settings. The JMX port, for example, used to be open by default on Tomcat back in when it was new, I think. It took a few versions before they actually changed it to off by default, but it was bundled with a lot of other frameworks and tools that were basically vulnerable to JMX injection, simply because it was in the right side for most people. And if you think, but I don't use it, nobody knows about it, that stuff is in the documentation. And I always say hackers always have time to read the documentation. We don't, but hackers do. They just read and they say, oh, look, there's a port that's open by default. Let's see if we can find it. Yeah. Couple extra slides. Why are you not working? All right, so there's some things I just said. So default ports, admin APIs, these are generally things that are part of these, the part of the framework that you might not be thinking about. And again, if you think, yeah, but nobody knows I'm using Spring. Are you sure? This is simply something that I can find on LinkedIn. It's redacted for who this is, but I can simply type in LinkedIn Java, Spring Boot, and then find a whole bunch of people working with Java and Spring Boot, and then I can look at what organizations they're working for, and if they were in the consultancy, I can maybe even find out what client they're working for, and then I can deduce, that client is using Spring Boot. Interesting. Again, this is for hackers. They have time to figure these things out. And so it's more public than you think. So that's my third and fourth point actually. So you get transitive dependency risks. Anything that the framework pulls in is automatically also a risk. And you get these free security risks, especially if you're not aware of them. And yeah, so that's the part maybe that you're not using and is not necessarily impacting your application. But there's also the part that you might be unaware of. So frameworks can also have like a beautiful API in the front end, maybe beautiful documentation. But if you take a step back, look at the inside, they might be full of holes and taped together components. There might be some bugs living in there. And these are all in your application. You get them for free. And there might be some unexpected features in there, like if you do something with databases or things, automatic flushing, and these things can be very hard to debug also. You suddenly see unexpected behavior of the application, think, what's happening? I'm not doing anything. The framework is apparently doing something. And continuing on this, in recent years, there's been some posts about people actually inserting malicious codes into open source projects. There's plenty of this as well. There are actually completely obfuscated crypto miners that get pushed into a PR somewhere. And if you ever want to do something like this, just ask Jan how you can put obfuscated code that everybody thinks is just comments, but is actually just executable code. That's entirely possible. And last year, this was an ongoing story where somebody was actually investigating a piece of malware that had been found in 35,000 repositories on GitHub. And what it did was if you had this malware in, it would be quiet, you wouldn't notice it, but on your startup, it would package your configuration with keys, secrets, and everything, and would send it to some server somewhere on the dark web, and all your keys were leaked. So that's another one. You get some free malware miners if you're not careful. I don't think we want that. I mean, if we want miners, then at least we want them to mine them to our own wallet, right? So I'd rather add it myself than have someone else add it. Okay. Next point is something that may not be very obvious once you start working in our industry. And that's that frameworks also tend to cause a sort of loss of knowledge. And there's another nice meme that's probably also familiar to people, where front-enders can get really pissed off if you send them a 200 with a JSON message that says error. This happens a lot. Why does this happen? This happens probably because the backender that's developing this application doesn't know a whole lot about HTTP and just probably thinks I have to pass an error to the backend. I have no time for reading the documentation because I'm not a hacker. I have a paid job and I have to complete this story. So I'll throw an exception, and Spring has this nice exception translator. So if I throw this exception, Spring can translate it into this nice JSON message that says there's an error. And oh yeah, if I do it in my browser, then I get this weird 4 something can't work. So I'll just make sure that it sends 200 and then my error message. Perfect. But that's not how the HTTP protocol was designed. That's not how it's supposed to work. And this just can happen simply because you step into a project that's working on a high abstraction level and you're unfamiliar with what's beneath it, especially if you're new to the industry and these things have not been taught to you. And that's especially if you get errors. I mean, we can get a fantastic high-level framework that gives us all these beautiful automation things. Think, for example, Kubernetes. And then somewhere along the way, you start something up and you get host unreachable. And then you have to figure out host unreachable. Most people will probably think, I don't know what that means. I don't even know where in the stack this is supposed to be happening, because it happens way down on the networking stack. And if you're not familiar with that, you've only ever done kubectl, apply, and those things, you might not know what this error message means. And it can feel very, very daunting. You can start to feel like, oh, I don't know anything. Imposter syndrome, hello. That's an easy way to get lost in these things. And last week I was talking about this, and we came up with this idea that over time our industry creates higher and higher abstractions. And the point where you start working in your career is the point on the ladder where you start your knowledge and your experience. And it's easier to move up. You know, if there's a new abstraction layer that takes away some of the jobs that you had to do repetitively, it's easy to move up. But if you step in on a higher point, it's harder to move down, because then you have to start looking under the hood, figuring out what's going on, learning what's happening beneath those abstractions. So this is what ChatGPT turned that story into, so it's quite nice. So higher abstractions at top, lower, down below, and two people at different levels. It's quite nice. So that's also what, if you're, especially as a junior, you come into a project and you only learn to program by using that particular framework, you might not be that compatible with other things. You might not be able to fix certain issues on yourself because you don't know what's underneath. Cool. So, well, the list is almost done, but it's not done yet. We also have this nice image from XKCD. It's actually inspired by some talk about the guy that's maintaining curl. You know, that's the open source tool you can use from Linux to call any HTTP address that's lovingly maintained by one single person in Canada or Alaska, I think. So there's so much built on top of that thing that he built. But if for some reason, maybe he stops working on it, he passes away, and nobody maintains this anymore, we have built loads of stuff on top of it. And especially if this is part of your transitive dependencies in your framework, you're getting this risk as well. And the JavaScript framework got a really nice wake-up call on this topic a couple of years ago, when there was this flame war between a large company that wanted to have a package name, because that was their company name, but the package name was already taken by an open source developer who had created just LeftPad. And that guy got pissed off, he deleted his library, and the whole internet broke. So that's sort of SPOF for the entire JavaScript world out there. So these external dependencies, they are a risk, and they can actually be very hard to have changes done in them. What if you have a change request or you have a bug? Sometimes you just, okay, I just need this fixed and then I can go on with my job. But then I say, oh, we don't have time for this, we are working on ChatGPT integration. I don't need ChatGPT integration, I need my bug fixed. But yeah, good luck getting that voted on GitHub for them to work on. So you're dependent on the people maintaining the framework. They have sort of have to work for you as well. So frameworks can feel like this sometimes. You're working on them, maybe at first it was nice, and then at some point you think, oh, this thing is keeping me back, it's slowing me down. What can I do about this? So, question, is it all bad? What if we're not frameworks, then what should we do? Should we not use frameworks at all? Well, that's not what I'm trying to say. What I'm trying to say is, we tend to stick to the frameworks that we do. You know, you start on a project, you pick a framework, you stick to it. And people tend to put on blinders and say, no, we're working with this framework and this framework only. But there are other frameworks. And these other frameworks, I consider them as tools. If you go to a carpenter and you say, why do you have different kinds of hammers? He says, well, there's a purpose for each one of them. Yes, they're all hammers, but if I have to put a window in and I use a metal hammer, I'm going to break the window. But if I have to drive a nail in with a rubber hammer, I'm going to break my hammer. So every hammer has its own purpose. And the point is, you have to know when to use which hammer, and you have to have the courage to switch between hammers. And then maybe courage is not so big when you're doing a home remodeling thing, it's just picking up a different hammer. But in a project, you might feel invested. You might say, we've been working on this project for 3 years and it's fully integrated with Spring, and now we've run into this issue. Why, if I switch now, I have to do everything again? Sometimes that's what you need to do, or at least consider. I mean, before we changed this Spring to Vertex, obviously we didn't just say, oh, well, let's just throw out Spring and see if Vertex works. No, we considered it. We considered some others and say, well, Vertex does meet our requirements, so let's just build it in Vertex. But I think in our industry, it really is a point of courage. It's kind of like technical debt. You have to have the courage to say, we have technical debt, we have to fix this. Technical debt might also be, we have this framework and it's holding us back. If we switch to a different framework, we might be able to go forward again. But it takes courage. And I understand we had a sort of luxury position where we were in control of our own local architecture, but if you have an architecture board and chapter leads who all have opinions about this is going to be hard. Next thing that I think we should do with frameworks is be curious. Don't just grab a framework, write some stuff in it, and expect it all to work and just say, oh, it's fine, it works, I don't care how it works. Be curious, read some documentation, go look at the code. If you're running into problems, download the source so your debugger can step to the framework as well. Just be sure that you teach yourself how does it work. And then you're basically moving down one step on the ladder of abstractions, and you get more knowledge about things that happen underneath. And you might even be tempted to go one step further down at some point and just generally know more about computing. So be curious, learn about the differences between frameworks as well, because there are differences and they might help you more than just sticking to one. The next thing I say is be critical. And this is especially of the part of the risks that you take. So if somebody comes running in and says, oh, there was a new framework released, let's go with this framework and just throw out the other one and let's build this one in and then release it and we're done. You might want to be the guy that says, or girl, by the way, guy or girl says, whoa, let's have a look at this framework first. Have you read the documentation? Does it match our needs? Does it have anything we don't want? Is it maybe known for its CVEs? Does it have other security implications? Because I think you'd rather be the person that slows this very enthusiastic person down and then finds what big risk your company is taking by just suddenly running after the next hype, than being this guy, right? So it's nothing worse than you think, I have this fantastic idea, I've been to a conference, I saw a new framework, I'm going to put it in, and then you put it in production, and then the next day somebody calls, why is our database empty? I don't know. So be critical and read the parts in the documentation that are usually reserved for the last part of any development cycle. I know I don't generally read the part about deploying to production first, but it has information about what the framework needs to be resilient in the production interface. Usually they say, well, once you're moving to production, turn these and these features off and you're good. Because this actually was in the Tomcat documentation back in the day. It said, if you're deploying this server in the production, turn off these ports. Nobody read it. So, stay critical. I think I'm going great for time. I have no idea when this ends, but so what I've been trying to say here right now, if you take one thing away from this talk, is that you are not your framework. Your framework is not the one that decides how you build your application, how you build your services. You're the one that chooses the framework. And you're free to choose another. And that's my talk, and I guess I have plenty of time for questions.
Yeah, thanks. Earlier today I heard somebody advocate J-Link to reduce attack surface for things you don't need.
Mm-hmm.
And how far do you think that would mitigate the risk of like putting in stuff that is only exposing you to danger?
Yeah. So the question is, in another talk, somebody was saying J-Link, you can use J-Link to prune things away from your application that you don't need, like parts of modules that you're not using. And how is that impacting the safety of your getting these dependencies in? Well, J-Link actually just takes away things that are not accessed by your code or by code that's loaded automatically. And so usually the part that it prunes away is also not the problem area. The problem area is the things that are started by default. So J-Link will also see, yeah, these classes are being accessed. We are starting a server, so I can't prune it away. So those things stay in. So if you would do that on like Spring Boot, and you say, yeah, but I don't use the management port, and say, yeah, well, it's being turned on, so that's not pruned away either. So I'm afraid J-Link is not going to save you here. Thanks. Any other questions?
Well, it's not a question, more a tip. I think if you stick to the clean architecture, then you'll also be able to isolate better the framework you're using. Therefore, probably you'll be more keen to switch another one if needs be.
Yeah, so it's not a question, it's more of a tip. If you use clean architecture, hexagonal architecture, it's probably easier to switch from one framework to another. And that's a good tip. Usually I get a question that leads me to give that tip, because usually I get a question, how were you able to change your service from Spring to Vertex in like a few days? And that was because we said, well, we want Spring on the outer boundary of our application, but not on the inside. So what we had to do was rewrite the boundary layer for Vertex, and the rest stayed the same. And that's basically, if you do clean architecture, then you have that as well. So your ports may be changed, but the rest doesn't change. Yeah, so thanks for the tip. Anyone else?
You made let me try to kind of give back to what you said about frameworks. So your point is, be critical, be curious, don't be afraid of changing frameworks. You haven't mentioned libraries. And I think distinguishing library and framework is more interesting one and more eye-opening to some people, like what the library actually is.
Yeah.
This library does not impose structure.
Exactly.
Application unlike framework. So what you've done with Spring, you made sure Spring is on the outer boundary, and you built applications without Spring inside. So you had to work around essentially the framework to have that. If you use library, you don't have this problem. This library is like a hammer, it's a tool. Right? You use library to connect to Postgres. Postgres driver is a library. It
Exactly.
does not infect your application. It doesn't affect your application like that. So like I work on Aaron. Aaron is a library. So we deliberately don't transform and make it a framework. A lot of people will say, let's add this feature, let's add this stuff. Why not make it a framework? Because no, this has to be a tool that you can always use, and not something that will, infect and make things.
Yeah, so I'll paraphrase for maybe people that haven't heard it exactly. So you're saying, well, I haven't talked about libraries. I only talk about frameworks, and frameworks have their risks. Be curious, be critical, etc. While using libraries takes a lot of these things away that I've been talking about, and that's actually I agree completely. So if you have a small library that fixes one of the things that you're working on, that's probably a better choice than bringing in a large framework that also has that feature, but you're not using all the other things. And it used to be more that we used libraries and not a framework, but some libraries started growing into a framework, and now people always say, yeah, but framework is nice, it's centered, I'm feeling comfortable in here, and that's, so yeah, if you start small and you just use libraries, you have a lot of these things that I call as risks, they either fade away or they become way more manageable. So yeah, libraries over frameworks. Cool. Anything else? If not, thank you for your attention, and enjoy the drinks later on and have a safe trip home.